Okay, we are picking up in 5.3 where we left off yesterday. And as I mentioned, you guys already have this, I think, right? We had found the increasing, decreasing intervals. We had found mins and maxes. The justification, if you're trying to justify that something is increasing or decreasing, a function is increasing or decreasing, your justification is that the derivative is positive or negative, respectfully, okay? If you're trying to justify a maximum or a minimum, again, we're using the derivative. I mean, it's the idea that the original function changes from positive to negative, or increasing to decreasing, or decreasing to increasing. But your justification is generally based on your derivative. So if your derivative changes from positive to negative, that means the original function is changing from increasing to decreasing, and thus a max. Okay? So, justification. Okay? Save this thought for free response type problems. How you explain something if necessary. Okay, example 5. For each statement below, sketch a function that represents the results of the first derivative test for a continuous function y equals f of x with a critical number at x equals c. So, we get to get creative here. I think I have some options. Obviously, it's going to be one of those things where there's not just one option here. So on A, we need to sketch a function that has an absolute minimum at x equals c, because f prime of x changes sign from negative to positive at x equals c. Thoughts on what we can draw here?
Below u, c. Yeah.
Could you pretty much draw a parabola?
Yeah.
Okay, and we're not saying that parabola has to touch the x-axis, but the minimum is above c is what we're saying, or above or below c technically. Okay, so yeah, I have a fancier. I mean, mine in my notes is more along the lines of. But okay, now, can it just be a parabola?
Yeah.
Yes. Okay. We're looking absolute minimum. Absolute minimum means it is the lowest point, yes? So the graph has to be going up, okay? And then the idea that the derivative sign here, the derivative would be negative, here the derivative would be positive. So your derivative is changing there. Okay, B. Oh, I know. Sorry, real quick. I just looked at my notes. The other thing I've written in here is that the derivative at c would equal 0, right? Because it's an absolute min. So, not something you have to put in there, but. Okay. B. F of x has a local maximum at x equals c, because f prime of x changes sign from positive to negative at x equals c. Okay. Well, all we care is that we're trying to make it a local max at x equals c. Okay, I agree. There's going to have to be a local min in there. I'm trying to think of a way you could draw it without a local min. You're going to have a local min in there too.
Down and back up.
Yeah. So like my drawing, and this is kind of what Tate traced in the air, was something like this, because when x equals c, is there a max? And it's a local max because it's not the highest point on the graph. It's just a high point locally. Okay. Again, notice it says the derivative changes from positive to negative. And again, the derivative at c would be equal to 0. It would have a horizontal tangent line. Okay, so we had local versus absolute. Okay. C. F of x has no local extrema at x equals c, because f prime of x is greater than 0 for all x greater than 0 and is strictly monotonic. Could it be a line? I'm checking the whole definition of monotonic and make sure that doesn't. A function is said to be monotonic on an interval if the first derivative does not change sign. So I think it could be a line. No local extrema. And f prime just says that f prime of x greater than 0 just says the slope is positive. Okay, so that means it's an increasing function. Yeah, I think it could be a line. I had something else in mind, which is why I was... Okay, I don't see why a line couldn't work, but I also had more along the lines of like a curve, where it's a cubic curve, so to speak. I had something along those lines. I don't see why a line couldn't work also. Okay, where, you know, if you'd done a line, it's the same idea, it's increasing, right? So the key is that there are no local extrema and it's increasing. Okay? D. Since f prime of x is negative immediately on either side of x equals c, the function f of x has neither a local max nor local minimum at x equals c.
Would x equals c be
Not an asymptote.
Could it be a?
Because these are no asymptotes, because that's what I was saying. I thought it said somewhere. This is a continuous function. These are continuous functions, so no breaks, no asymptotes. What else was said?
Is it a sharp case?
Well, but there's no max, no min.
Well, what if it's absolute? Yeah.
But the derivative wouldn't, if it's a, so if we're doing this, I'm going to erase it. My derivative is positive and then negative. And it says negative immediately on either side.
Oh,
So it's just a straight line going down.
Straight line, or guess what I'm going to do? The cubic curve. Because here you've got the idea that it's negative immediately on either side. You've got that negative derivative. Like over here it was a positive. Here it's a negative. I feel like D is just different words for asking about the reverse of C. Like I feel like D and C are the same thing, except one says positive and one says negative. Okay? So, questions there? Moving on to 6. Okay. Unfortunately, I am erasing screens today because I just didn't have enough room in my graphs. Okay, 6. Find the exact values of any relative extrema on the function g of x on the interval 0 to 2 pi and justify. What are we going to do? Derivative. What is the derivative of 1/2 x minus sine x? Derivative of 1/2 x is 1/2. Derivative of sine is cosine, so it just stays the same sign. And then we're going to do what? Set it equal to 0. When we solve it, you're going to have, add the cosine x over, so cosine x equals 1/2. When does cosine equal 1/2?
I'm 3.
And?
The bottom one, which is
5.
pi over 3.
So I'm taking it you remember the example we did the other day, because didn't we
Yes.
have to do that exact piece? So that's knowing your triangles, your chart, whatever, and then all students take calculus. You need cosine positive, which is bottom right quadrant. Okay. Now, with that in mind, we need to do a sine chart. Okay. With this sine chart, pi over 3 and 5 pi over 3. We are looking at the derivative here. Because remember, we want to know where is the derivative positive or negative. We don't have a nice factored form here. You just have 1/2 minus cosine x. And so you're basically just going to have to, I don't know, kind of guesstimate, but do the math to an extent. So like right here, a number less than pi over 3, I would use 0, right? 0 is easy. So if you do 1/2 minus cosine of 0, well, cosine of 0 is 1. 1/2 minus 1 is going to be negative. Okay? Like, I prefer it when we can use factors. We just can't here. In between pi over 3 and 5 pi over 3. Pi. Pi would be easy. So 1/2 minus cosine of pi. Cosine of pi is negative 1. So 1/2 minus negative 1 is going to be positive. Okay. And above 5 pi over 3, 2 pi. 1/2 minus cosine of 2 pi. Well, cosine of 2 pi is going to be 1. So 1/2 minus 1 is negative. And I don't know, I know you guys use your quadrants a lot, don't you? Me personally, I go back and think about our cosine curve. And I know this is 1, I know this is negative 1. Here we have 0. In the middle is pi. Over here is 2 pi. And then these cut throughs are pi over 2 and 3 pi over 2. I don't know. You know, you guys are fine to use your quadrants and the 0, 1, that type of stuff. But I think about my sine and cosine curves. But, okay, so what do we know here? Where the derivative is negative, my graph will be decreasing. Where the derivative is positive, my graph will be increasing. So there we're talking about the original graph. And then what do we know then? Pi over 3 is going to end up being a what? A min. 5 pi over 3 is going to end up being a max. Now, okay, what did they ask me to do? Find the exact values of any relative extrema of the function on the interval 0 to 2 pi and justify. So that means, when it says find the exact values, we're going to have to know g of pi over 3 and g of 5 pi over 3. Exact values means they're not technically asking for decimals, are they? So, if you put pi over 3 in,
Wait.
No, whoa.
Oh, original, sorry.
We're going into the original because we want to know the values of the mins and maxes. So, so 1/2 times pi over 3 is going to be 3 pi over 2, right? Minus, what would sine of pi over 3 be? If cosine of pi over 3 is 1/2, cosine of pi over 3 is 1/2, sine of pi over 3 is, what's the other one? Square root of 3 over 2. Okay? That's your exact value. It's not pretty, but that's your exact value. If we do g of 5 pi over 3, well, 1/2 times 5 pi over 3 is going to be 5 pi over 6 minus the sine of 5 pi over 3. Now, sine of 5 pi over 3, guys. Okay, it's going to be the same as sine of pi over 3, yes?
Yeah.
We just have to figure out what the sign is, the positive, negative sign. And then, so now I'm saying all students take calculus.
Oh, wait, sine is.
5 pi over 3 is down here, and sine is negative, yes? So that's going to be a negative, so it's going to be minus a negative, or in other words, plus square root of 3 over 2. That's your exact. Okay? Do we need to brush up on the trig some still? Okay. Officially, it did say justify. Okay, and it also, we talk about answer the question being asked down here. Are you looking for the extrema, like the y values, or are you looking for where the extrema occurs, which are the x values? This said find the exact values of any relative extrema. That means your focus here are the y values. Okay, the extrema values are your y values. So, what was pi over 3? It was a min, right? So I can say okay, g of x has a relative min of 3 pi over 2 minus square root of 3 over 2. That's that exact value, right? And you can say at x equals pi over 3. And why was it a min? It was a min because g prime of x changes from negative to positive. Are you seeing that? It's a min here because it changed from decreasing to increasing, but in terms of the derivative, which is your justification, it changes from negative to positive. The other piece is that g of x has a, and you could use the word local, you could even, you could even just say min or max, but it has a relative max of, and I'm going to give this value of 5 pi over 6 plus square root of 3 over 2. And that's happening at x equals 5 pi over 3. Since g prime of x changes what do we change from? Positive to negative. Okay? And I cannot stress enough what it says down there at the bottom. Answer the question being asked. Okay? I get lenient with you, and I probably shouldn't, about, you put, and I guess the common mistake here is be hesitant about, I let us get away with just putting the ordered pair. Technically, if they want the value, you're putting the Y value. Okay? So that's where it's better to state it something like this form. Okay? Okay. Gosh, I don't know. We have what we need there. Okay. Let's at least look at 7. We might not do quite all of these because I'm stressing about time here. And they get repetitive, but yet everything has a good piece to it, which is why I hesitate. So, easier said than done. Okay. 7. Find the relative extrema for f of x.
Oh boy.
There's a reason I didn't skip some of these because, yeah, exactly. Oh boy, it looks big, doesn't it? Okay, where am I starting? Derivative. We've got that down at least, right? How do we do that derivative?
To the negative.
Okay, there's a power rule there, yes. So multiply by the 2/3 out front, keep the inside the same, subtract 1 from the power. 2/3 minus 1 is negative 1/3. Then it's chain rule times derivative of the inside, so derivative of the inside is 2x. Now, if I clean this up some, which I would like to do, I'm going to turn it into a fraction, because what about that negative 1/3 power? It's going to go to the bottom, and technically it's a 1/3, so it's a cube root if you want to write it as a cube root. Okay. And then what about the rest of this? 2x is on top, as well as, what else is on top? 2. 2 times 2x is 4x, and the 3 ends up on bottom. Okay? It looks a little bit neater that way, and more importantly, it's easier to work with. Now, where do critical values happen? Any place the derivative equals 0 or undefined. Now, how does a fraction equal 0? When the top is 0. So, one critical value is going to happen when 4x equals 0, because that's going to allow the derivative to equal 0. When does my derivative undefined? When the denominator equals 0. So you also have to set your denominator equal to 0. Now, there's only one important part of this denominator that really matters. I mean, I can set this whole denominator equal to 0, but think with me. The first thing I'm going to do is I'm going to divide the 3 away. 0 divided by 3 means it's still going to be a 0. Then, since it's a cube root, how do you get rid of a cube root? You cube it. Well, when you cube a cube root, you're going to get whatever's under the cube. When you cube 0, you're going to get 0. So really, the part that matters is x squared minus 4 equals 0. When you solve that, what are we going to get? Yeah. It's x squared equals 4, square root it, x is plus or minus 2. I never finished this over here, but if 4x equals 0, then x equals 0, right? And in case you want to write yourself a note, this was the derivative equal to 0. And over here was the derivative being undefined. Okay? Those were the two pieces and why we did that. Now, so what does that mean? We have critical numbers at x equals 0 and plus or minus 2. Okay? Okay. It asks us to find the extrema, so when we find those extrema, we're going to put 0, -2, and 2 on our sign chart. And keep in mind, what do we know? The graph is, there's a 0 here, and at 2 and -2, those are places my derivative is undefined. Okay. This is where I don't have, it gets a little sticky plugging into these pieces, but, okay, pick a number to the left of 2, -2, -3, and this is where you're just going to have to, I'm using this right here, so think about it. 4 times -3 is going to be a negative. The 3 doesn't matter. What matters is underneath here. So -3 squared is going to be 9. 9 minus 4 is a positive. A negative divided by a positive is going to be a negative. Are you with me there? If you want to, you just have to reason through it. You don't have to have exact numbers, just reason. What happens when you put in -1? You're going to have a negative on top, but -1 squared is going to be 1. 1 minus 4 is going to be a negative. Negative divided by a negative is a positive. Okay. What happens when we put in 1? 4 times 1 is positive. 1 squared minus 4, negative. A positive divided by a negative is a negative. Something to the right of 2, 3. Positive divided by positive there. Okay, so what do we know? If the derivative is negative, my original graph is decreasing. If the derivative is positive, my graph is increasing. We need to know the relative extrema. What do we have? At -2, there is a min. At 0, there is a max. At 2, there is a min. And this is kind of your own, this is my work. This is me just organizing my thoughts, organizing my work. It's not that you have to have all of that there, okay? Now, since they said the relative extrema, they're not just looking for the x values. They want the y values, okay? So you need to come up with the y values at -2, 0, and 2. Now, when we do this, I guess I put y here. I really shouldn't call it y. I'm going to call it f of x for less confusion. Mins and maxes, we're looking at the points on the original curve, so into f. Well, okay, -2 and 2 are easy, I just realized. Right here, guys, -2 squared is 4. 4 minus 4 is 0. When you plug in 2, you're going to get the same thing, right? 4 minus 4. And then when you put in 0, 0 squared minus 4 is -4. -4 to the 2/3. So that in my brain is the cube root of -4 squared.
16.2.
It's a decimal. I'm going to write it as cube root of 16. I think that's, yeah. You could also put it as a decimal depending on the scenario. Okay, guys. Officially, it said justify. Are you getting the idea of justify? F of x has, what do we have? We had a max, a relative max of the cube root of 16. That can be expressed in other forms too. And that is at x equals 0, because f prime of x changes from, what do we do for a max? We change from positive to negative. Okay. And then what else do we know? F of x has relative min of 0 at x equals 2 and x equals negative 2. And why do mins occur? Because f prime goes from negative to positive. And again, the symbols I draw with my number line are what helps me keep my brain organized there. Okay. 8 and 9, they really are doing the exact same thing we've just been doing. It's just a difference in equations. Okay. I think what I'm going to do is I'm going to skip 8 and 9 so we can get into 5-4 a little bit here. Now, here's what I'm going to say. Can you look at 8 and 9 if you want to?
Yeah.
Yes. Okay. The notes are online. And I have all of chapter 5 available right now, don't I? I just decided to do it that way this time to make it easier. Which means you can look at the guided notes to look at those two for 8 and 9, and especially if it becomes an issue for homework. And then you've got the homework problems, okay? Okay. Do that homework for tomorrow.